it could reproduce exactly the same connections and pathways that are going on in your brain. And this is where this idea comes from, that you can upload your consciousness to a computer.
It is 70 years since the pioneer of computer science and Enigma codebreaker Alan Turing argued that if we cannot distinguish between a computer's response and a human's, the computer is intelligent and can be said to think. According to this Turing test, computers are already thinking and intelligent. But critics argue that this is nonsense and that it remains unknown how to test for intelligence or consciousness. The computer, they argue, is nothing but a machine able to produce outputs that copy human responses, but it does not understand these outputs or have any intent in producing them. Should we conclude that thought and consciousness are unobservable, and there is no brain process or computer test that identifies them? Was the Turing test, in fact, a highly successful rhetorical device to encourage us to conclude that machines might one day think, and now embedded into the very name artificial intelligence? Or is this misguided, and should we instead conclude that computers are already thinking beings, and a modified version of the Turing test can provide a test for consciousness? To help us unpack this, we have a panelist of 4 fantastic speakers. On our screen, you can see Yoshua Bengio, who is recognized worldwide as one of the leading experts in artificial intelligence. His pioneering work in deep learning earned him the 2018 AM Turing Award, which is known as the Nobel Prize of Computing, with Geoffrey Hinton and Yann LeCun. Hilary Lawson, to my left, is a philosopher and renowned critic of philosophical realism. His main work, Closure, A Story of Everything, has been described as the first non-realist metaphysics. Sabine Hossenfelder, to my far right, is an external member of the Munich Center for Mathematical Philosophy, who specializes in foundations of physics. She is also one of the world's leading science communicators. To my immediate right is Nick Lane, a professor of evolutionary biochemistry at the University College London and a best-selling author of 5 critically acclaimed books on evolutionary biochemistry. He argues that consciousness is a biological phenomenon. What a spoiler. So you're all probably very familiar with the format, but just in case you're not, the deal here is we're going to have some opening pitches from each one of our speakers, 2 minutes to set up their stall, as it were, and then after that we're going to get into the main meat of the debate, okay? So the question that I would like each of our speakers to address is there a test for thought or consciousness in humans or even computers? Yoshua, could you take us away? 2 minutes, please.
Thank you. Yes. Well, I'm going to start by saying that biology is fairly strongly, and chemistry as well, telling us that human brains are machines. They are biological machines, obviously, designed by the forces of evolution rather than by humans. And there's no reason to think that consciousness and thought wouldn't be the result of computations going on in the brain. And in fact, the progress in AI suggests that this hypothesis, which is not only supported by biology, but is also supported by the advances in AI, as we see machines becoming better and better at doing things that brains do. A few words about the Turing test itself. It's it was never really defined in a sufficiently formal way, so even AI researchers disagree whether we have passed it or not. But my opinion is that at some level we do. However, I think Turing overestimated the question of whether mastering the language and passing for a human is sufficient to really have all of our cognitive abilities. There's been enough work since ChatGPT came out to show that there are still areas in which these systems are weak, especially reasoning and agency and planning. But you see advances, at each generation. Lately, we've had O1 from OpenAI, which is breaking through previous barriers in terms of reasoning. One additional thing I would say is I'm afraid that we're treating consciousness in a way that's similar to how people were thinking about life, a few hundred years ago, as having some kind of magical spark. But as science has been peering into how life works, and more recently, more and more into how consciousness works, the mystery of life has disappeared. There's more and more research in biology, neuroscience, but also connecting to AI on the particular functions of consciousness, because the word consciousness is pretty vague and actually encompasses many different aspects. Mm-hmm. And as we are lifting a bit of that veil, I think the mystery will go away. However, it's also possible that we have a built-in, human tendency to see something special in us and in others in front of us, other humans, and that even if we have scientific evidence and that we understand how consciousness works in the brains and that we could choose to build conscious machines with that, I think we shouldn't. We might still feel that there's something special that's not material, but it doesn't mean that it's true. I'll stop here.
Fantastic. Hilary, could you tell us what you think? Is there a test for thought or consciousness in humans or in computers?
I don't think we have a test for consciousness in the sense of a litmus test, as well, there it is. And that's because I don't think we can find consciousness in the world. It looks on the surface of it as if the fact that we can't identify consciousness out there, or we don't have any examples of identifying consciousness out there, is an empirical accident. That we somehow have looked there and we haven't yet found it, but maybe some point in the future we might be able to somehow find this thing which is consciousness. I think that's a bit of a logical mistake, category mistake. Experience is necessarily experience of something. This is a point that Kant made in the 18th century. And thus, if you think about it, when you experience something else. You don't just experience the experience, you experience the idea of an experience of something else. That relationship of as it were, yourself to an other is embedded in the very idea of experience. And you are the observer in that sense. But you can never find the observer in the observed, because by definition it isn't. The observer is engaged in observing, and the observed is something other. So I don't think that you can find, in principle, consciousness out there in the world. It's a category mistake. That doesn't mean to say that things can't generate responses which are like consciousness, and possibly there could be a test for that. One other thing I'd like to say just about the Turing test is that when Turing first put this proposed this, which was in 1950, and in his paper, he began by saying, can machines think? It's a perfectly good question. But he abandons the question on what seemed to me to be rather spurious grounds. First of all, that he can't define machine, and he can't define thinking. And instead, he proposes an alternative question, which is, let's say that if a machine can imitate how humans use language, then it should be said to think. And then on that principle, he concluded that computers could think. Well, this is not a legitimate move. If a machine can imitate aspects of what we do as humans, it doesn't mean to say that the machine has the characteristics of humans. I mean, if you have a mousetrap, it can probably catch mice better than most of you out there. But that doesn't mean to say it has the experience of catching the mouse when it does so, does it? Your calculator can add up better than you can, but it doesn't mean to say it thinks when it adds up. That's just a mistake. It doesn't apply. So why is the Turing test even plausible? And it's because he introduces this idea of language, that if somehow the computer can function, or the machine can function as well as we can with language, it should be said to think. And I think the problem there is that we imagine that the computer understands language by understanding the meaning of this word and the meaning of that word and putting them all together, and then thinking, oh, well, if it can use it as well as we can, it must be thinking. But that's not what a computer is doing. It's got nothing to do with understanding any word. No computer understands a single word. All it is doing is it has a mathematical way of predicting what an intelligent member of that language user group would use as the next word in a sentence. And that mathematical calculation enables it to create both respond to and create sentences. Has nothing to do with understanding.
Fantastic. Sabine?
Yeah, thank you. So as you heard in the introduction, I'm a physicist, and I think it will surprise absolutely no one that I think consciousness is physical. It comes about from the interactions of particles in the human brain, and exactly what it is difficult. So to answer this question, is there a test for thought or consciousness in humans or computers? Not yet, but we're working on it. There are lots of theories for how you could measure consciousness in systems generally, not just in the human brain, but in any system that's made up of many components that interact with each other. Lots of mathematical theories. I recently read a review article about this by Robert Kuhn, which lists 200 theories of consciousness. I sent this to a friend who was very insulted that his theory wasn't on the list. So I think this gives you an idea. I think they're all wrong. I think we're very far away from being able to quantify consciousness, but we'll get there eventually. And I think it's possible, so I think I have to disagree with you. I actually do think that one of the main ingredients to consciousness is the observer observing themselves. And I think that's something which can be, in principle, mathematically quantified at some point. I don't know how to do it, but in principle, it should be possible. With regards to the Turing test, I never really thought of it as being a test of thought or consciousness, but it's more like a kind of a benchmark test for development. It's like when my first child had her first tooth, I was like, look at this, we made a human being and it's got a tooth. And so this isn't particularly meaningful to anyone except the parents possibly, but it is a sign of development that is proceeding. And this is how I've been thinking about the Turing test. It tells you we're making progress, we're on the path somewhere.
Fantastic, thank you. Nick?
So you already know what I think. I'm a biologist, therefore I think it's biological, obviously. You're a physicist. I think it's physics as well. So I think we always conflate things, and we're conflating here consciousness with intelligence. And consciousness is a word which conflates with itself as well. And I think for a long time, the hard problem in consciousness has been why is there a feeling that it's like to be alive, to do anything, to have any form of sensations, when in principle, with a philosopher's zombie, you could behave the same, everything could be algorithmic, and yet we know that we have feelings. And so this is the hard problem of consciousness. And the reason it's hard is that I don't personally think that neural networks is the right way to ask that question about feelings. That's not to say neural networks can't become extremely intelligent because they're aware of the observer and so on. So intelligence, I have no problem. It's the question of feelings that I am more interested in. And I think feelings are probably very grounded in how we think of ourselves as human beings, and probably grounded deeply in morality and so on as well. So I think if we can't understand feelings biologically, we're getting nowhere. Now, in terms of that, there's a nice quote from Shakespeare, of course, never the philosopher could endure the toothache patiently. And we really can't. There's not much intelligence in the toothache, but it's a searing pain that we all know what it is. And it's a very much a biological pain. There's no reason why quantum physics should come up with the toothache. This is a biological problem that we're dealing with, and we don't know what generates it. Why would this neural network generate a feeling of pain and an apparently identical looking neural network be unconscious? We cannot answer that question in those terms at the moment. I would take it back. I think feelings evolved by natural selection, therefore they have utility. Where did they arise? Not in these neural networks. In my mind, at least, anesthetics work, for example, on pretty much all animals. Some people even say plants, but certainly protists, which will effectively crawl around. You can stop them crawling around by anesthetizing them with the same anesthetic gases that we use. That says that there's something about consciousness which is a property of living things. And how do we get at it? Well, it turns out nobody really knows, even now, exactly how anesthetics work. This is a 100-year-old mystery. Some people will tell you, oh, we do now, but the arguments are not fully coherent. It seems that they affect mitochondria. This is my way into this question and why I have an interest. The mitochondria are the power packs in cells, which are providing you with energy. It's a little bit, if you pull the plug out, obviously the system goes down. It's more interesting than that. Mitochondria were bacteria once, and bacteria, think of it as a little packet with a membrane around it interacting with the world. Inside that little packet, you've got 1 billion reactions every second. Sure, you've got genes, you've got enzymes, metabolic machinery, but what you're doing is 1 billion reactions a second, second after second after second. How the hell do you know what you're doing? How do you integrate that and say, okay, I'm in trouble here, I should move over there? That, I think, is the level where a feeling is beginning to come in. It's a biological system taking some kind of top-level appraisal of exactly how it's doing in relation to the environment and what it should choose to do next. And I think that's where feelings come in. It's linked with agency, with the ability to move, with the ability to make a decision, and it's got nothing at all to do with neural nets.
Wow, okay. None of those were 2 minutes apart from Sabine's, but that's fine. Let's dive into that first theme. So we've actually all touched upon this. So the first theme is kind of about this question of whether or not we can explain thought and experience in terms of physical material. Sabine, can I turn to you and ask you to sort of kick us off on that? Because you sort of acknowledged the importance of physical material and the sort of substrate, and so did Nick afterwards. But what do you think? Can we actually explain thought and experience in those
I think
terms?
the way that the question is phrased is a little bit weird, because I think it's not so much the material that matters, but the connections of the system, which could be made of many different types of materials. And at the moment, we don't really know just exactly what is necessary about the substrate, as you put it. Like, what are the essential physical ingredients to consciousness? You just said it's something to do with mitochondria. There's a lot of discussion in physics about whether quantum processes play a role in consciousness. Some people say yes, other people say no. Basically, the brief summary is we don't really know. But either way, it's something physical, and consciousness is a property that we emergent. So it comes about from the interactions of other things. And I think that there is no particular reason why you can't replace the individual particles on some level, so the individual constituents that interact. And this is where this idea comes from, that you can upload your consciousness to a computer, because the computer has another substrate, so to speak. It's not biological, it's made of silicon or what have you. But it could reproduce exactly the same connections and pathways that are going on in your brain. And it seems to me that this is likely to be correct, but we don't really know.
Can I add something here?
Yes.
Turing is also known for his work in computer science with the Turing machine, as it's called. Yeah. And what it's theoretical work that essentially shows that any computer with sufficient expressivity can emulate any other computer. And everything that, for example, Sabine was talking about when she talks about the interaction between physical entities is really a computation. It's information that flows from one place to another and combines in various ways. And so at a theoretical level in computer science, it can be demonstrated that there's no reason that the computation going on in our brain couldn't also happen in another substrate. Now, it might be inefficient in another substrate, but that is a different question. But in principle, we should be able to have machines that have the same kind of information processing. And of course, thinking looks very much like information processing. Now, consciousness, of course, looks more mysterious, but some of the work of my colleagues and myself are trying to peer into what is looks like the most mysterious aspect of consciousness, which is subjective experience. And we come up with physical models of dynamics that explain a lot of, if not all of, the properties that we associate with subjective experience. So I think there will be more theories, and there's no reason to think we will not converge on the physicality and the computational properties that give rise to the kind of computations going on when we are conscious.
That's really interesting to me. So you've basically said it could be biological substrates, it could be silicon chips, it doesn't make a difference because computation is effectively the basis of consciousness. Is that correct? Yes. And therefore, if it's computing, then that goes on. But you've all also alluded to this sort of subjective experience thing that comes along with it too, right? So you're saying, are you saying that the basis of consciousness is the capacity to compute in any form? And then secondarily, no, okay.
No, I'm saying that the ability to compute is the building block, but consciousness is more than computation. So first of all, we lump a lot of things into the word consciousness. So I think that's not good from a scientific perspective. And it's important to break it down into particular capabilities and types of computations.
Yes.
And I think that the one where philosophers really have been debating a lot is subjective experience. In other words, somehow how we experience things when we are conscious. And it turns out that properties of subjective experience, like ineffability and richness of the experience, as we're not able to put in words what we feel. The fact that it's also personal, that your experience is always going to be different from mine. The fact that it's fleeting. All of these properties can be explained by some particular mathematical models. Now, it doesn't mean this is the answer, but the fact that we are able to come up with mathematical theories which have a computational nature that reproduce these features of subjective experience, for me, is a strong indication that we will pierce the apparent veil of mystery about consciousness.
May I
please
say something on the nature of substrates and computation? I mean, I completely agree with virtually all of that. In terms of computation, if you think of a neural net as a series of switches that are on or off and networking in one way or another, yes, all of that is computation. But neurons are not just a switch. They're a lot more complex than that. And I alluded already to this question about why do some neural nets give rise to a conscious experience and others don't? Now, it's interesting to me that the people who, from a kind of scientific background, have explored consciousness, biologists are amazingly underrepresented. Biology is a really conservative discipline, I have to say, and biologists don't like making fools of themselves. I quite like making a fool of myself, so I'm here. But the people who do are mostly neuroscientists, and they're thinking about the human brain and about the network properties of the brain and emergence at the level of the brain and so on. What I was talking about before, in a bacterial cell, 1 billion reactions a second, all of which can go wrong, all of which are happening in water, you've somehow got to come up with, in a split second, in a nanosecond, some kind of idea of how am I doing right now? Do I need to leave? It's a biological decision that you need to make with wetware. And I think that's very, very different to just silicon chips and dryware. So we're probably less good at the computation. I mean, I think undoubtedly we already are less good, but we're doing something else, which is where feelings are coming in.
To continue watching this video, click the link in the top left or in the description below, or visit iai.tv for more debates and talks from the world's leading thinkers on today's biggest ideas.